quartiles for grouped data. So I want us to have a question. We have a question and then we see how it is calculated. But I want you to write this one first and say that for the lower quartile, which is actually given as Q1, on the lower quartile or Q1, it is normally calculated by L plus 1 over 4N minus C over F, then you multiply by R. For the lower quartile, it is 1 over 4N. Remember the median is N over 2, but for the lower quartile, it is N over 4 or 1 over 4N. Remember L is lower class limit of lower quartile class. N is the lower class limit of the lower quartile class. N is the total frequency. C is cumulative frequency. C is cumulative frequency above the lower quartile. Cumulative frequency above the lower quartile class. And then F is the frequency of lower quartile class. L is the frequency of the lower quartile class, and then R is the class interval. The class interval. In this case, you need to know that the key thing is for you to locate the lower quartile class. The key thing for you to be able to solve all this is for you to locate the lower quartile class, because that is our reference point. And you need to know that the lower quartile class, let me just call it Q1 class, is the class where 1 over 4N will fall on the CF. The class where 1 over 4N will fall on the CF, it is going to give us that. It is going to give us the lower quartile class. Remember, for the median, we normally do N over 2, and then we locate that one on the CF. But on this, we normally do 1 over 4N. So this value here where there is N is very key. Even if we shall go to the deciles, percentiles, where we have N, that is where we are going to locate the class, where we are going to have the quartile, the decile, or the percentile that we are looking for. In this case, 1 over 4N will give us the lower quartile class. That is it. When we talk about the upper quartile, when we talk about the upper quartile, of Q3, we should know that Q3 is given by L plus 3 over 4N minus C over F times R, where L is the lower class limit of Q3 class of the upper quartile class, and then N is the total frequency C is cumulative frequency above the Q3 class, and then F is the frequency of Q3 class. F is the frequency of Q3 class, and I is the class interval. On the same note, Q3 class is the class where 3/4n fall on the CF. So that is the most important thing for you to be able to know. This part, 3/4n, will give us the upper quartile class. 1/4n will give us the lower quartile class. n/2 or 1/2n will give us the median class. So you need to know this is the part that is very crucial, that is going to give us the class that we are interested with. So we can do a question to demonstrate that. I want you to look at 2014. That is November 2014. November 2014, question 5B. November 2014, question 5B. So from that, we are supposed to get the cumulative frequency. Always we must calculate them using the cumulative frequency. So in this case, the first frequency is 10 plus 18 will give us 28, plus 20 will give us 48, plus 30 will give us 78, plus 18 is going to give us 96 plus 12, 108 plus 20, 128 plus 12, 140, 148, 150. So that is our cumulative frequency. So if you add this one, it's supposed to give you also 150, and therefore our n, our n is equals to 150. Our n is equals to 150. With that now, we can be able to determine those quartiles. If we start with the Q1, which we know is given by L plus 1 over 4n minus C over F times I, we need first of all to get the Q1 class. The Q1 class, which will be given by 1 over 4n. In this case, it is 1 over 4 times 150, which gives us what? Join. 150 divided by 4?
That is 7.5.
That is 7.5.
Yes.
Okay. So we need to locate where does that 7.5 fall in our cumulative frequency. Obviously, it is going to be on 48.
48.
This class, the class Q1 class, the class from 15 to 20. So after locating that class, we can now be able to get the values for the remaining letters. So our N is going to be 15, the lower limit. Our N, we know it is 150. Our C is the cumulative frequency above the 48, which is 28.
28.
Then is the frequency of this class, the individual frequency, which is 20.
20.
I is the difference, 20 minus 15, which is 5. Those values, now you can come here and say that Q1 on the lower quartile is going to be equal to L, which is 15, plus 1 over 4n, we have done that one to find 37.5, minus C, which is 28, over F, which is 20, and then we multiply by 5, which will be equal to 15 plus 37.5 minus 28.
9.5.
9.5 over 20 times 5. Can you do for me this? 9.5 divided by 20, and then whatever you get, you multiply by 5.
2.375.
2.375 plus 15 is going to be 17.375. So that is the Q1, that is the lower quartile. That is the lower quartile. The key thing is to get the lower quartile class, which is given by 1 over 4n. After getting that, now you locate the class. The moment you have the class, the other values, the L is going to be the lower limit of that class. C is the cumulative frequency above the class that you have selected. And then F is the individual frequency of that class, which is the frequency here. And I is the class interval, which is the upper limit minus the lower limit. Like that. After getting that, remember we have obtained, I want to note it somewhere. Q1 is that 17.375. I love this. We now calculate the Q3. It is now going to be 3/4 of n. It is going to be given by 3/4n. So what you do, you locate the Q3 class. You locate the Q3 class. That is our first assignment. You just do this part of n. 3/4 times 150, which is our n. That one gives us what then?
112.5.
Sorry?
112.5.
112.
Yes.
0.5. So we come here, where is our 112.5? It can only be in 128. We cannot take 128. We normally take the figure that is slightly higher, which is this one. So the class is 35. The class is, that is Q3 class is 35 to 40. The moment you have that class, the other values now can be obtained. So L is the lower limit of that class, which is 35. Our N, we know is 150, it does not change. Our C is the cumulative frequency above. We have picked 128, we picked the one that is higher, 108. Our F is the individual class, the individual frequency for this class, which is 20. And I remains to be 5 like that. Therefore, Q3 would be equal to 35 plus 3/4n, which we calculated to be 112.5, minus C, which is 108, divided by the frequency, which is 20, then we multiply by 5. This one is equal to that 5 plus. What is 112.5 minus 108?
4.5.
Sorry?
4.5.
4.5 over 20 times 5, which will be equal to 35 plus, and you do for me this computation, 4.5 divided by 20 times 5.
1.125.
1.125. So the answer here is 36.125. That is the upper quartile. Q3, let me note here, is 36.125. I want us now to calculate the median. The median is actually Q2. We have been doing it, but we can do, for the sake of this question, the Q2 or median, it is normally given by a half of n or n over 2. So we need to locate the Q2 class, which will be given by 1 over 2 times 150, which will be equal to 75. Then 75 falls here, where we have 78. That is where the 75th item is going to be found. And we take that class, the Q2 class, is equal to 20 to 25. That, then we are able to get the L, which is 20, the C, the one that is above the 78 that we have picked, which is 48. The F is the frequency of this class, which is 30. The I is the class interval, which is half. And N remains to be 150. So our median is going to be equal to L, which is 20, plus into bracket 1 over 2n or n over 2, which is 75, minus C, which is 48, over F, which is 30 times 5. So this one will be equal to 20 plus 75 minus 48. Are you still there?
4.5.
Sorry?
4.5.
That is the answer.
No, when you multiply, when you minus 75 minus 48, divide by 30 times 5. 75
You get?
minus 40, minus 75 minus 48.
Yes.
You'll get 27.
Yeah. Over that.
All over that.
5. So the final answer is supposed to be 20 plus 4.5. Divide 27 and that here, and then you multiply by 5, what you get?
4.5.
4.5. Right? So the answer here is going to be 24.5. So in other cases, you can be told now to calculate the what we call interquartile range. Interquartile range, remember we said it is normally given by Q3 minus Q1. That is the upper quartile minus the lower quartile. In this case, the upper quartile was 36.125 minus 17.375, which will give us what?
18.75.
18.75. Then we can also be told to calculate the quartile deviation, also known as semi-interquartile range. Semi-interquartile range. Semi-interquartile range or quartile deviation. It is normally given by Q3 minus Q1 over 2. In this case, it is like getting the average. Yeah? It is like getting the average. Q3 minus Q1 is 18.75. Then you divide by 2. This one will be equal to 9 point what?
9.375.
9.375. So that is what you can be asked as far as the quartiles are concerned. You can be told to get the upper quartile and the lower quartile, and the question can go ahead to ask you to get the interquartile range, the quartile deviation, and all that. Any question? Okay. Okay. If you are comfortable with that, then that is a plus. I want us now to talk about the deciles and percentiles using the same illustration. So you can just write the next bit is the deciles. Just write the deciles. Deciles. And you say that deciles, you say that they are values that divide a distribution. They are values that divide a distribution. Values that divide a distribution into 10 equal parts. Values that divide a distribution.
Values that
Divide a distribution. Values that divide a distribution into 10 equal parts. That we divide a distribution into 10 equal parts. They are represented as follows. They are represented as follows. So you can have maybe D2. This means the second. D2 means the second decile. And actually, the second decile is obtained by L plus 2 over 10 N minus C over F times R. It divides the distribution into 10. So everything is going to be over 10. Remember the quartile, it divides, or the quartiles divide the distribution into 4. That's why we have over 4. 1 over 4, 2 over, the other one 2 over 4, which is actually a half for the median, and the other one is 3 over 4 for the upper quartile. But for the decile, because it divides the distribution into 10 parts, we normally have it over 10. And the procedure is the same. So we can also have maybe D4, which will mean the 4 the decile. And this one will be calculated by L plus 4 over 10N minus C over F. Then you multiply by R. Then you can have maybe the 7th, not the 7th, but the 7th, which means the 7th decile that is calculated by L plus 7 over 10N minus C over F times R. So, and we can have maybe the 8th decile, the 9th decile, and the 10th decile like that. So the deciles can be decile 1 all the way to decile 10. They cannot be more than that. So you need to know if it was the 8th decile, this one would have been 8 over 10. It was the 6th decile, it would have been 6 over 10n. That is how this part changes. And remember, this part is very crucial in giving us the class. Because for us to be able to calculate the second decile, then we must know what is the second decile class. We must have the second decile class, which we normally use this. If we want to calculate the fourth decile, then we must have the fourth decile class. If we want to calculate the seventh decile, then we must get the seventh decile class. And these parts are the ones that are going to be calculated to give us those classes, to give us the value that will mean where the decile lies. Maybe we can calculate this one. Let us calculate the second decile using the same data. We need to get D2 class. The second decile class is going to be determined by 2 over 10n, which is the same as 2 over 10 times 150, which is actually equal to that. So the question we ask ourselves, on the cumulative frequency, where does the 30th item fall? The 30th item falls on this number, where we have the 48, where we have 48. So we take this class as the D2 class. So these are D2 class will be equal to 15 to 20. D2 class will be 15 to 20. Therefore, 15 to 20. The L is going to be 15. Our L we know is 150. Our C is going to be 28. Our F is going to be 20. And our I will still remain to be 5. And therefore, our A2 will be equal to 15 plus 2 over 10 n we calculated and we find it is 30 minus c, which is 28 over f, which is 20 times 5, which gives us 15 plus 2 over 20 times 5. What do you get?
Zero 0.5.
15 plus 0.5, which is actually 15.05, which is actually 15.5, and that is the answer. That is the answer. So if we are looking for the fifth decimal, then we shall locate the D5 class by doing 5 over 10n. Okay. Maybe we can calculate another one, and then we move on to the percentiles because they share a lot. If we want to get to the D8, which is going to be given by L plus 8 over 10n minus C divided by F times I, then we need to get a D8 class. The 8 class is going to be given by 8 over 10 times 150, which will be equal to what? 15 times 8, 120. Where is our 120? 120 will fall here, where we have 128. So if that is the case, then 35 to 40, the 8 class will be equal to where we have 35 to 40. The class of 35 to 40. So in that case, our L is 35, our C is going to be equal to 108, our F is going to be 20, our I is going to be equal to 5, and we know N is 150. So D8 will be given by 35 plus 8 over 10n is 120 minus C, which is 108 over F, which is 20, then we multiply by 5. This one is going to be equal to 35 plus, this one is 12 over 20 times 5, which will be equal to 35 plus
3.
3.
Yeah.
Which then is going to be equal to 38. That is there, and actually that is how we get the decimals. That is how we calculate the decimals. So you can be able to calculate. The key thing is to get the class for that decimal. And remember, we are saying to get the class, you just divide. If it is the 4, 4 over 10n. If it is the 9, it is going to be 9 over 10n. To do that computation, it is going to give you the value that you can be able to use to get the decimal class. With that, the decimals are done. We go to percentiles. You can write this that they are values that divide a distribution. They are values that divide a distribution into 100 equal parts. Values that divide a distribution into 100 equal parts. That divide a distribution into 100 equal parts. They are denoted as follows. They are denoted as follows. P, maybe P10, this one means the 10th percentile, which is calculated by L plus 10 over 100 N minus C over F times R. Percentile, because the value divides the distribution into 100, we normally have it over 100. Then, if for example you are looking for the 35th percentile, T35, this one means 35th percentile, which is given by N plus 35 over 100N minus C over F, then you multiply by R. You can also be interested in getting P70. This one means it is the 70th percentile, which is going to be given by L plus 70 over 100N minus C over F times R. So you can be able to get any percentile from 1 all the way to 100. So that is it. But the key thing again, you must be able to get the class for the percentile that you are calculating. If you are not calculating the 10th percentile, then you must have the 10th percentile class. And here, the P10 class is going to be found by doing 10 over 100 times n. If we use our example, our n was 150. You realize that our P10 is where we have the 15 item. We find that the 15 is going to be here in 28. So this one, P10 class, is equals to 10 to 15. The class of 10 to 15. And then you can go ahead and get the values now. If you locate the class, obviously our L will be the lower limit of that class. Our C is the cumulative frequency above, which is 10. Our F is the frequency for this class, which is 18. Our I is going to be 45. You substitute in the formula, you get it. Similarly, you must locate here the T35 class, which will be given by 35 over 100 times n, which is 150. You find the answer there, which is how much, Joel? 35 times 15 divided by 10.
52.5. 52.5.
52.5. So you can be able to go to the cumulative frequency and realize that it is supposed to be here. Don't pick any number that is less than whatever you're looking for. You take the one that is slightly more. So this is our class. Then you pick the values and then you are done. So basically, that is what you need to do as far as the quartiles, deciles, percentiles are concerned. That is what you can ask for that. So I want us to go to the last area of this chapter, which is on skewness and kurtosis. Skewness and kurtosis. Just a minute, don't just stay on for just 5 minutes. I pick some notes here and then we continue. Just a minute. Oh, good. When umekuja. Okay. How umeamua aje? How have you decided? Eh? Okay. So we are running on a skewness, huh? Skewness, you can note that it is the measure of symmetry. It is the measure of symmetry in a distribution. It is a measure of symmetry in a distribution. The measure of symmetry in a distribution. And then you say a distribution can either be negatively skewed, i.e. majority of the data are towards the right. Majority of the data are towards the right. And the left tail is longer. So it can be presented like this. And actually, an example is something like this, where you have data that is behaving like that. You see, this tail is very long, and then majority of the data they are towards the right. That is where we have a lot of data here. And then this tail is very short, but this one is very long. That one we say it's negatively skewed. That is negatively skewed. Then we can have a normal. We have what we call normal distribution. Normal distribution. Yes, here you draw. You draw that, you sketch. But make sure as you draw, this one should have a very long tail, and then once it gets there, it drops very fast. That one is negatively skewed.
I'm asking, Mr. Makori.
Yes.
I'm asking hapo kwa skewness, kuna any notes ume take down ama?
Nimedictate kama line mbili.
Sentence mbili?
Line mbili.
Like?
2 lines.
Okay.
So the negatively skewed is that. Then a distribution can be normal. Then you say this is when the mean, median, and mode. This is when the mean, median, and mode, they are all equal. The mean, median, and mode, they are all equal. And the data to the left and the one to the right, the data to the left and the one to the right are balanced. The data to the left and the one to the right are balanced. So such kind of a distribution is normally said to be normal. So at the center here, that is where we have the mean. That is where we have the mode and the median. That is normal. And it's actually balanced. The way you can see to the right and to the left, it is the same. Then the last one, it is what we call positively skewed. Data can be, or a distribution can be positively skewed. Then you say that it is a distribution in which majority of the data, distribution in which majority of the data, distribution in which majority of the data falls to the left, majority of the data falls to the left, and the right hand side, and the right hand side, and the right hand side has a long tail. The right hand side has a long tail. Right hand side has a long tail. You find that now this one is going to appear like this. Let me draw it properly. It comes. That is what we call it's a positively skewed. Majority of the data fall here. Majority of the data fall here, and then the right hand side has got a very long tail. Having noted that, we can go to the Pearson's coefficient of skewness. Pearson's coefficient of skewness. Then you say that it is calculated using two approaches. Calculated using two approaches. A is the coefficient of skewness is given by x bar minus mod over standard deviation. B coefficient of skewness is given by 3 times x bar, 3x bar minus median over standard deviation. So you can use those two to compute the coefficient of skewness. The coefficient of skewness. And I don't think now you have any trouble. You know how to get the mean, you know how to get the mode, you know how to get the standard deviation. Therefore, you can be able to substitute them. You can be able to substitute them and get the figures, then you calculate that. Then we briefly talk about kurtosis. Kurtosis. Then you say that it is the pickedness. It is the pickedness of a distribution. It is the pickedness of a distribution. Pickedness of a distribution. Just a minute. So this one. So we continue and say this. Then you say this kurtosis can be of 3 types. Kurtosis can be of 3 types, where we have the first one is what we call leptokurtic. Then we say that this is a distribution. This is a distribution with a sharp. A distribution with a sharp. A distribution with a sharp peak. A distribution with a sharp peak. It is represented as follows. It is represented as follows. That is left. It must be sharp and very high. Sharp and high, that is what we call leptokurtic, sharp and very high. Then we have what we call mesocartic. The second type of kurtosis is mesocartic. Then we say that it is a distribution. It is a distribution with a normal peak. This one has a normal. It has a normal peak. A distribution with a normal peak. It is normally represented as follows. This is what we call mesocartic. It is a distribution with a normal peak. It is not sharp and it is neither very flat. Mesocartic. The last type of a distribution, under the kurtosis is what we call platycartic. Platycartic. Then it says that it is a distribution with a flatter peak. A distribution with a flatter peak. Distribution with a flatter peak is what we call platycartic. And then it is represented as follows. It is a distribution that has a very flat peak, or the peak is very flat, something like that. This is what we call platycartic. Platycartic kind of distribution. So we have the leptocartic, which has got a very sharp peak, normal, which has got a moderate normal kind of sharpness, and then the platycartic that is almost flat. These ones, they can actually be represented in one graph sometimes. You can find them being represented in a single graph, and you find that they are drawn like this. That. Then there's another one that is behaving like that. Then there's another one that is behaving like that. You need to know that the one that is highest is always the lepton. The leptocartic. This one will be mesocartic. And this one is going to be platycartic. They can be in one, and maybe you are told to identify which is which. The highest and the most sharp is rectal. The moderate is the meso, and then the most flat is the platy. So I would like us to do one more question. That is actually the end of the syllabus. If you are now able to do all that we have covered, then you should be getting very good marks on everything. Yeah? But I want us to do one question. That is November 2016. It doesn't have anything to do with this, huh? But it's still under statistics. So we are talking about November 2016 question 2B. November 2016 question 2B. Where you're told that the table below shows the grouped frequency distribution of marks obtained by 50 candidates in a zonal mathematics contest. My interest in that question is because we have got some values not given, they have been indicated by X and Y. So we have the marks. Those are the values given. And then the question says that on the required part, you determine the values of X and Y given that the mean of the distribution is 61.2. Remember, we have been given our X bar. Yeah? We have been given X bar 61.2. X bar is 61.2. And we have also been told that the table below shows the group frequency distribution of marks obtained by 50 candidates. So if we add the frequency here, the summation of F should be equal to 50. That is what we need to understand. And then we ask ourselves, how do we get the X bar? X bar will require us to have X and also for us to have Fx. That one is a requirement for us to get X bar. So the X, we know they are the midpoints. X, they are the midpoints of the classes from 24 to 30. What is the midpoint, Joy?
27.
27.
Yeah.
In the one in 35. 45, 55, 65, 75, 85, and 95. Those are the x values. What about the fx? 54.
Yeah. 175. 175.
This one
45.
x, because we don't know x.
495.
This one?
495.
This one will be 65. Y.
600.
600.
Yes. 425. 425.
425.
285.
285. Now, what I want you to do is to add the nodes: 54, 175, 495, 600, 425, and 285. The ones that does not have x and y. Not to it.
2034.
That it is going to be 20.
34.
Or remember there is what? Plus 45x plus 65y. So that is the summation of fx. So that is the summation of fx. You add the nonce, then plus 45x plus 65y. Then after that, then we know the x bar is calculated by the summation of fx over the summation of f. That is what we know. Therefore, 61.2, which is our x bar here, should be equal to 2034 plus 45x plus 65y divided by the sum of f, which we know is what? 50. If we multiply by 50 by 50, 61.2 times 50. Yeah, that's 16 is equals to 2034 plus 45x plus 65y. Let us bring this one. That is 60 minus 2034. Yeah. 10 or 6. Is equals to 45x plus 65y. That one we can call it equation 1. We can refer that to equation 1. Then we come here. If the sum of this is 50, what is the value of the total of the nodes? If we add 3 plus 5 plus 8 plus 9 plus 5 plus 2, then we can say here 50 is equal to 32 plus x plus y. So, therefore, 50 minus 32, which is 18, 18 is equal to x plus y, and that is our equation 2. That is our equation 2. So those two equations can be solved now spontaneously. You can come here and say 45x plus 45y is equal to 1026. X plus y is equal to 50. You can use any of the methods that we know. We have talked about matrix method, we have talked about elimination, substitution, all of them. So, what are we supposed to do in this case? So we can use, let me use a substitution method. From this equation, we can make it to be x is equal to 50 minus 1. X is equal to 50 minus y, and we substitute x is equal to 50 minus y in equation 1. We substitute in equation 1. Remember that is 1. This is our equation. Sorry. This one is our equation 2. This is where we have equation 1. Like that. So where we have x, we put 50 minus y because they are equal. So we shall have 45 times x, but x is equal to 50 minus y plus 65y is equal to 1026. 45 times 50.
2250.
Yes, minus 45y plus 65y is equal to 1026. 65y minus 45y, that is 20y. So we can remain with the 20y here is equal to, is that okay? Is equal to 10.
Excuse me.
Yeah?
Excuse me, Mr. Makori. You know, you have said equation 1, equation 2 is supposed to be.
Yes. Can you come again? Somebody is saying, and actually I can see something is not okay.
Equation 2.
It is
Equation 2.
Oh,
It's 18, not 50.
I have seen it. Actually, this one was equal to 18. Yeah. Thank you for that. Yes. Therefore, this is 18. That is 18. So we are supposed to get 45 times 18. Yeah. 810 minus 45y. Okay. So 20y, this one will go minus 810. So 20y, 1026. minus 810. 216. So y is equal to 216, 20.
$10.8.
Then
10.8.
10.8, which is approximately level. Okay. If we put 10.8, remember there are people, I don't know why it comes to a point, but that is what it is always giving us when we take class. So the moment you have found y, so you can come to this equation where we say x is equal to 18 minus y. So x is going to be 18 minus 10.8. So x will be equal to what? 7.2. So which is approximately 7, and this one is approximately 11. approximately 7. So those are the values. So those are the values. So in this case, whenever you are told, actually, if you find this question coming in an exam, they will give you the total frequency and they will give you the mean. They will give you the total frequency and they will give you the mean. And then you can create the values of X and Y as we have done. So you must have 2 equations. You solve those equations simultaneously. So I feel we stop there. That is the end of the syllabus. So the remaining duration, we can use it now for revision. We can use it for revision. And our first revision will be next week on Thursday. Tomorrow I might not be around. So we do it from Thursday in the morning, and then if you are free, you can also be joining the day group. So that is it. Any question? If there is none, then let us stop there. I'm going to share the recording for those who are not in class. I'm going to share the recording of this so that you can be able to follow. But it's going to have some gaps, some noise and some breaks in between, but you can be able to follow what we have done.